Hi, my name is Leopold Talirz, and over the next few minutes I'm going to introduce you to the AiiDA Plugin Ecosystem. We're going to talk about what an AiiDA plugin is, about how AiiDA discovers plugins. We're going to have a look at the AiiDA Diff Demo plugin, and finally I'm going to talk a bit about how you can go about developing your own plugin. What's an AiiDA plugin? Simply put, an AiiDA plugin is just a Python module that extends AiiDA core, where AiiDA core just provides the basic infrastructure, meaning it provides the database model, it provides the provenance graph, provides the workflow engine, and it provides the REST API. And AiiDA plugins can provide new types of calculations that describe which input files your simulation code needs, how it should be called on the command line. They can provide parsers for the outputs of simulation codes. They can provide workflows that string multiple calculations together and add error handling. You can provide new data types. You can provide new Verdi commands that, for example, visualize a new data type that you have added. You can provide support for new schedulers, new transports. You can connect to external databases, and in the future, you'll also be able to add new endpoints to the AiiDA REST API. Just a note on nomenclature. One AiiDA plugin package can bundle several AiiDA plugins, and you can then distribute your package, for example, on the Python package index, and you should register your package on the AiiDA plugin registry. If you go to the AiiDA plugin registry on aiidateam.github.io/AiiDA registry, you will see that we currently have 50 plugin packages registered. It also contains statistics on the type of plugins that these packages provide. So, for example, the AiiDA Siesta plugin provides 2 calculations, 2 parsers, 2 data types, 3 workflows, and a couple of other plugins. And so the question arises, how does the AiiDA plugin registry know what kind of plugins a particular package provides? And the method for discovering the plugins that packages provide is called. The types of problems we're trying to address here are the following. For example, AiiDA Siesta provides a new STM calculation type, and as a user of AiiDA Siesta, I now need to know where do I import it from and how do I use it. Another example is AiiDA Wasp provides a new Wasp Podcar data type, and now as a developer of AiiDA Wasp, I might want to add a new Verdi command for this data type so that users of my package can directly inspect the contents of this data type. So how do I do that as a developer? As a user, again, I might want to list all the workflows that I've installed on my machine or all the calculations that I've installed on my machine. And so overall, the goal is to let plugins extend existing AiiDA interfaces so that AiiDA users already know where to find and how to use the functionality. What is a Python entry point? Python entry points associate Python objects with free-form identifiers, meaning with a string. And this is now an example of an entry point definition from the AiiDA Diff Demo plugin that we are going to look at later on. So what you need to do is you need to have an object that you want to point to, in this case a so-called diff calculation class. You need an identifier, so a string, in this case diff, that points to the path of this object inside the AiiDA diff package. And you need to place this identifier inside a group, inside an entry point group, in this case AiiDA.calculations. These groups are defined by AiiDA core, and when AiiDA core starts, it will go through all of the entry points provided in the AiiDA.calculations group in order to know which calculation types have been provided by plugins. How does AiiDA do this? This is something that you can do yourself in 2 lines of Python. You import package resources, which comes with the setup tools Python package, and you call the load entry point method. You pass it a distribution, which is simply the name of your AiiDA plugin package. You pass it an entry point group, in this case AiiDA.calculations, and you pass it the name of the entry point, in this case diff. And so we've stored this inside the diff calculation here, and if you print it, you will see that you get the actual class definition back. So this is, for example, what the calculation factory of AiiDA does behind the hood. And so what can AiiDA plugins provide? For each of these plugin types that I mentioned before, there are corresponding entry point groups defined by AiiDA Core. And so by placing entry point names inside these groups, you can add new calculations, new parsers, workflows, etc. And you can list all of these available groups using the Verdi plugin. This is just to mention that AiiDA Core uses entry points as well. For example, these are the two transports defined by AiiDA. We have the local transport, which simply runs things on the machine where AiiDA installed, and the SSH transport, which is how AiiDA connects to remote computers, for example, supercomputing centers. And this is the list of schedulers that ship with AiiDA. So we have the direct scheduler, which simply directly runs the calculation you want to run. You have the LSF, PBS Pro, SG, Slurm, and Torque plugins. But if your supercomputing center has a custom scheduler that is not supported by default, you can simply create a scheduler plugin to support it. A few notes on the reentry package. Package resources, as we have seen, provides a registry and lookup for entry points, and it does a couple of integrity checks, so it can be a bit slow. And since we use entry points in the Verdi command line interface, we need it to be quite responsive. And this is the reason for existence for the reentry package. This acts as a separate entry point cache that is about 10 times faster. And in order to refresh this cache, you need to run the reentry scan command that you've already seen probably a couple of times during the tutorial. So this is why you have to run reentry scan after installing a new plugin. AiiDA Diff is a demo plugin that is meant as a template to get you started with plugin development. So one thing you can do is you can simply go to GitHub, clone the repository, and start modifying things. AiiDA Diff wraps the diff executable, so it's a simulation code that computes the difference between two files. And why did we choose diff? Because it's available on almost every Unix system by default. It already has command line options, for example, for case insensitivity, and it takes two input files and it produces one output file. So many other simulation codes have to be called in a similar way, and so by modifying this plugin, you can already cover a large number of use cases. Let's have a very quick look at how some of this works in action. I wanted to show a quick demo of the Verdi plugin list command, which uses the entry point mechanism. So if you type a Verdi plugin list on the command line, you will get a list of the entry point groups that AiiDA Core provides. And you can then add one of these groups at the end of the command, for example, AiiDA.schedulers, to get the list of scheduler plugins that are currently installed. So these are the ones that are provided directly with AiiDA Core. But you can also have a look at, for example, the AiiDA.calculations entry point group. And if we have a look there, we will see two of them that are provided with AiiDA Core. This arithmetic.add one is actually one that you will look at in the calculation plugin tutorial. But we also see that there's this new diff entry point, which is provided by the AiiDA Diff plugin. And you can now append this entry point name again to the end of the command. AiiDA plugin list AiiDA.calculations diff, and you will get as an output a description of this entry of the class that is behind this entry point. So AiiDA knows that in AiiDA.calculations there should be calculation job classes, and calculation job classes have a description of the type of calculation that they provide, and they have a specification that tells AiiDA which types of codes they require, which types of inputs they require, and which types of outputs they produce. So in this case, the diff calculation takes 2 input files, as well as a parameters dictionary that can be used to define extra command line parameters. And it produces an output file which contains the diff between the 2 input files. I wanted to very briefly show the code repository of the AiiDA diff plugin, which you will find on GitHub under the AiiDA team organization. The repository contains quite a large number of files, many of which are not really essential to get started with plugin development, but these are files that you will find useful as you progress with the development of your plugin. There is a detailed README as well as a documentation of all of the repository contents. And if you scroll down a bit further, there's even links to a couple of videos from the last tutorial that we had, where I explained the content of a couple of these files in more detail. If we go back to the code, the AiiDA_diff folder is really the core content of the repository. This is the actual code of this plugin package. You will see that AiiDA diff provides a parser, it provides a calculation, it provides a new data type, it provides an extension of the AiiDA command line interface, and a couple of helper codes. And with this, let's go back to the presentation. Finally, some free time investment advice from my side. Learn how to write tests. I know that scientific programmers often are reluctant to write tests because, I mean, we come from usually writing our own Python scripts for doing small things, and then these scripts grow and grow and grow. But often we are the only user of these scripts, and so we know that the scripts work, or at least we are convinced that the scripts work, and so why should we invest time in writing tests? Of course, this paradigm kind of breaks as soon as you start giving your script to a coworker and they no longer they realize that the script doesn't work for their use case, or even once you start modifying your script in a significant way and start breaking other parts that you weren't aware of. And so having tests that tell you which parts of your script are tested and confirmed working in the long run are a big time saver. In AiiDA Core, we suggest using PyTest, and the AiiDA diff plugin already has a number of tests written in PyTest. I'll end with some guidelines on plugin design. The first guideline is start simple. So when you're writing a new plugin, you don't need to start with a copy of AiiDA Core. You can use existing classes like the dict class representing Python dictionaries, or the single file data class, which is simply wrapping a file on a file system. And you can start by writing only what is necessary to pass information from and to AiiDA. The second guideline is don't break data provenance. So you should store at least what is needed for full reproducibility of your calculations, and that is partly your responsibility as a plugin developer. Then try to expose the full functionality of your code. So if your code can do it, ideally there's some way to do it through your AiiDA plugin. This is quite different in concept from workflows. Workflows usually are written with a particular purpose in mind, and they try to work with as little user input as possible, while AiiDA plugins ideally expose the full functionality of the code that they're wrapping. That doesn't mean that every functionality of the code is exposed in the same way. So maybe you focus on one particular subset of features and leave a backdoor for some of the more advanced features of the code that you don't have the time to make super user-friendly, you don't have the time to add validation, but ideally there should be a way to use the code. The next guideline refers to a very generic concept, which is not to rely on internals of the framework that you're using. The AiiDA documentation specifies which part of the AiiDA API are considered public-facing. So this is usually the lower levels of nesting in imports. And if you start using functionality at deeper nesting levels that is not part of the public API, this functionality may break between AiiDA releases and break your plugin. Finally, parse what you want to query for. So it can be very helpful to make a list of which information you want to parse into the database. So this is things that you might want to query for. So for example, certain parameters of an input file, certain single valued outputs of your code. Then another level is the files that you want to store in the AiiDA repository for safekeeping, maybe because they're very expensive to compute. And finally, the category of data that you can afford to leave on the computer where the calculation ran, risking that this calculation will eventually be deleted, but that is not essential because if you ever need this information again, you can easily recompute it because you have all the information necessary. There are a couple of places in the documentation where you can find information on how to write plugins. There's a how-to guide on running external codes, which includes instructions on how to write a simple calculation and a parser plugin. We have a how-to guide on creating a plugin package. And there's a plugins topic, which contains some more in-depth information on plugin, as well as the design guidelines. So to recap what we've learned, AiiDA plugin packages extend existing AiiDA interfaces through Python entry points. And when developing a new plugin, start simple, don't break data provenance, and start early with writing tests, because in the long term, it's going to save you lots. One last thing I wanted to mention is that while the AiiDA team who developed the core of the framework are mainly located at EPFL in Switzerland, AiiDA was really built with the plugin ecosystem in mind from the very beginning. And we do have a very lively network of plugin contributors spread across Europe and also starting to have contributions from outside, for example, from China. For the tutorial session on interfacing with external codes, you're going to have the choice between two options. I recommend option A for those of you who would like to learn how a calculation and a parser plugin work under the hood, but have no concrete plans yet to write a plugin for an external simulation code, maybe because the plugins for the codes that you need already exist. This option should easily be doable in the 1.5 hours that are available in the time slot, and at the end you will have a basic calculation and parser plugin that you can modify. Option B is recommended if you have a concrete plan of wrapping in a simulation code with an AiiDA plugin. Here you will use the AiiDA plugin cutter to template your plugin package. So the AiiDA plugin package template comes with a number of features, such as templates for documentation, for tests, for continuous integration tests, etc., which add complexity that is not necessary for understanding the basic concepts, but are very useful if your goal is to write an AiiDA plugin package. So, and this task is really an open-ended one. So it's meant to get you started in the most efficient way possible by having members from the AiiDA core team around whom you can ask your questions to, but don't expect to finish this task within the 1.5 hours time slot of the tutorial.